How can we quickly measure the vibration mode of this component using the VibroScan QTec scanning vibrometer? First, the VibroScan is aligned to the object. Everything that can be seen in the video image can also be measured. We proceed step by step, as clearly specified by the software, and calibrate the scanners using the 2D alignment. We set a few reference points, and the scan angles are aligned with the video image. There is also an automatic mode, which we will show you at the end of the video along with a few other hints. To define a coordinate system, we use 3 points in the 3D alignment: origin, axis, and plane. The values from the integrated LiDAR distance sensor, together with the scan angle, provide the 3D coordinates. A measurement grid can be set up quickly with just a few clicks and the built-in tools. At the end of the video, we show you how this can be done automatically with AI. We reuse the distance sensor in the next step and obtain the 3D geometry of the measured object. This allows us to display the measurement data in 3D later. The QTec interferometer delivers an optimal signal-to-noise ratio for clear results. To collect as much light as possible, we activate the automatic focusing function. That increases the signal level further and supports data quality. Before starting the measurement, we need to set the parameters for the measurement channels, as with any conventional data acquisition. Bandwidth and frequency resolution are already determined by the task at hand, so we can move straight on to the channels. Thanks to QTec, we can set the number of averages to a minimum, saving measurement time. We set auto range. If the amplitudes are too high at a certain point, this function automatically adjusts the level. With the quick setting, we adjust the vibrometer range so that the gain is approximately in the middle. Auto range handles the rest. We are now ready to start the scan. The two modes of the PSV software, data acquisition and presentation, allow us to analyze a different measurement while the scan is in progress. We take a look at our measurement. The vibration modes are available in frequency result form. We can now view them in 3D for analysis and export them for reporting and post-processing. The setup was quick and easy, wasn't it? It is child's play to learn how to use. Alignment, calibration, grid generation, measurement parameter setting, scanning, evaluation. Thanks to the QTec technology of the VibroScan, we were able to generate the necessary data for optimizing a component quickly, effortlessly, and with high precision, and make it available to the team. We would like to introduce a few more tools that make life easier. In addition to the laser interferometer and the LiDAR system, there is a third sensor, the camera. Image processing supports some of the steps we have already seen before. With 2D alignment, the laser position is detected and you simply need to click on the image and the laser will follow. An automatic mode is also available, known as alignment scan, which uses the measurement grid as a basis. The built-in AI recognizes the object, we just have to click on the areas of interest, and a measurement grid is generated. With good contrast, complex geometries can easily be automatically fitted with a grid. This concludes our quick overview of some of the other options available in the PSV software for measuring deflection shapes. Please feel free to contact us for a live or online demo.